Good morning to one and all. This is DLN Sai Jishnu from CSE Data Science, IAR College. Today, I will be explaining about Kcl and its applications. In this topic, we are gonna discuss about some of the certain things. First of all, introduction, Kcl, which is meant by Kirchhoff's current law, its applications, and the conclusion of the PPT. First of all, what is Ohm's law? These Kcl and KVL are related to the Ohm's law. If we don't know this Ohm's law, we cannot understand the KCl and its KCl and its applications. So it is directly or indirectly linked with Ohm's law. So first we need to know about the Ohm's law. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Introducing the constant of proportionality, the resistance 1 arrives at the usual mathematical equation that describes these relations. I is equals to V by R. And resistance, by this equation, we can calculate voltage and resistance. This is an Ohm's law. Now, we'll learn about KCl and its applications. In the previous slide, we discussed about the Ohm's law. In this slide, we will know about the Kirchhoff's current law that is linked with Ohm's law. Kirchhoff's current law, often shortened to KCL, states that the algebraic sum of currents entering and exiting at a node must equal to 0. Means the if there are 5 currents, that is 2 entering currents and 3 exit currents, the current at entering currents, the sum of entering currents is equal to the sum of exiting currents. This law is used to describe how a charge enters and leaves a wire junction point or node on a wire. Simply we say that to know the current in a wire or a junction, this law is useful, and Kirchhoff's current law is useful to measure the current at each junction. That the simple equation of the simple as we can understand that the equation to be understand it is I entering plus minus of I exiting is equals to 0, or I entering is equals to I exiting. That is current entering is equals to current exiting. Summarized in a phrase, Kirchhoff's current law reads as such. The algebraic this is the synonym sentence of the Kirchhoff's current law. To understand to understand the statement for ease for beginners, this is the simplest statement. The algebraic sum of all currents entering and exiting at node must equal 0. That is, if we assign a mathematical sign to each current denoting whether they enter or exit a node, we can add them together to arrive at a total 0, guaranteed. Together, Kirchhoff's voltage law and Kirchhoff's current law are a formidable pair of tools useful in analyzing electrical circuits. These, with the help of Kirchhoff's voltage law and current law, we can calculate or we can measure the electric circuits at, which means how we can calculate the voltage at each circuit by Kirchhoff's voltage law, or current by Kirchhoff's current law, or in a junction. And there are in any statement or in any scientific theory, there will be limitations and advantages. In the previous slides, we discussed about the advantages and how Kirchhoff's current law used for states that. In this slide, we will know about the limitations of KCL. I mean, Kirchhoff's current law. KCL is applicable on the assumption that current flows only in conductors or wires. While in high-frequency circuits where parasitic capacitance can no longer be ignored, in such cases, current cannot flow in an open circuit because in these cases, conductors are acting as transmission lines. This is the only limitation for KCL. And there are other limitations for KVL and Ohm's law. But in this PPT, we are going to discuss about KCL only. So the limitation of KCL is the only one, mainly one, only one. KCL is applicable on the assumption that current flows only in conductors and wires. That means it flows only in conductors and wires while in high frequency circuits, whereas what can we say in transmission lines or anything. So in these cases, conductors or wires are acting as a transmission lines. This is the only limitation for KCL. Now we are going to discuss about application of Kirchhoff law, current law. The practical application of Kirchhoff current law is to determine the amount of current flowing through individual electronic component in a circuit. Using that law, we can manipulate the current to the component by controlling the resistance to it. This means that the first statement that we said in the PPT, we will revise it once. Sum of the entering currents is and leaving current at the node must be equal to 0. This means the application of the main application, the only one or main application of Kirchhoff current law is to determine the amount of current flowing through individual electronic component in a circuit. This means there are 4 or 5 nodes or junctions in a circuit, but we need to know about junction 1 or node 1. By using Kirchhoff law in each junction, we can measure or manipulate, or we can measure the resistance of we can know the current through the junction which we want. This helps only for it through individual KCL is mainly determine the amount of current flowing through individual electronic components in a circuit. In this slide, as we discussed about application and what is meant by Kirchhoff's law, what is meant by Ohm's law, how they help us, what are the main limitations of this law. For the conclusion, for the experiment, it is found that in the series circuit, the current remains the same and the voltage divides according to the load connected. There is no specific conclusion for Kirchhoff's current law. So we need to conclude as it is linked with Ohm's law. We will get to know about the Ohm's law conclusion that will help to, or that will links with Kirchhoff's current law in this slide. It is found that in the series circuit, the current remains the same and the voltage divides according to the load connected. In series circuit, the Kirchhoff's voltage law is applied and the sum of the all voltages equals 0. For the parallel circuit, the voltage remains the same, however, the current divides into branches. In parallel circuit, Kirchhoff's current law is applied. The simple theory of this slide is, in series circuit, Kirchhoff's voltage law is applied. In parallel circuit, Kirchhoff current law is applied. That's it. From these two laws, we are gonna measure what the main things of the circuit: current, voltage, resistance, etc. Thank you. Thank you for giving this golden opportunity.